All right, this is the next video in our work on quadratic functions, and today we will be working with the quadratic formula and the discriminant. And we'll start off with an introduction and then do a few solved examples. So the quadratic formula is a formula that helps us solve for x when we have a quadratic equation written out in standard form and equal to 0. So this is standard form right here, and here you can see that it's equal to 0. So both of those things are really important. It needs to be in standard form and it needs to be equal to 0. By the way, if a quadratic equation was in vertex form, you could probably solve for x by taking square roots, dividing both sides, etc. Okay, you wouldn't need to use the quadratic formula. But often it's in standard form and we need to use a quadratic formula. So the formula is as follows: x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So a couple things to notice. The first thing is that we have a plus or a minus in there, and that's what gives us the possibility of getting two solutions for x. The second thing is we have a square root. Okay, so we're taking the square root of b squared minus 4ac, and maybe you can imagine that when we take the square root of a negative, we would get no solutions, okay, because we can't take the square root of a negative at this point. And then the last thing, a subtle point, but I want you to know, is that I said it's all over 2a. A lot of people make the mistake of just dividing the square root piece by 2a, but that's not correct. You want to divide the entire numerator by 2a. I'm going to clean some of this up a little bit and then just give you a couple definitions first off. So the first thing is the discriminant. And that's just a vocab term for the expression under the square root sign. So the discriminant here is b squared minus 4ac. And that's actually pretty useful because it tells us how many solutions our equation will have. So if b squared minus 4ac is positive, in other words, if it's greater than 0, there are going to be two square roots to that. So therefore, we will end up with two solutions. If our discriminant is equal to 0, when we take the square root of 0, we just get one square root. That answer is 0, and we will end up with just one solution. And lastly, if this discriminant is negative, like I was alluding to earlier, we can't square root a negative, and so we will have 0 solutions. And before we do some examples, there's one last piece that I want you to think about. There's hopefully a part of this quadratic formula that looks familiar to you, and that's negative b over 2a. Right? Do you remember that that's the x-coordinate of the vertex of the parabola? So if we do have any old random parabola with an axis of symmetry and a vertex, that x value right there is negative b over 2a. So we're really just adding and subtracting the b squared minus 4ac over 2a, the square root of that, to both sides. So that's why we get one x solution here and one x solution over there. That's a little bit more advanced, a little bit more abstract, but just know that there is a piece of the quad formula that has the vertex as part of it. But let's do some examples. So this first series of questions just asks for how many solutions. Okay, it's not asking us to actually solve for x. So what we're going to do is just find the discriminant, find b squared minus 4ac. And for every time that I do the quadratic formula, I really am careful at writing out carefully what a, b, and c are. I think that's a really valuable strategy, especially if you're new to this. So let's write out what a, b, and c are. And we could do this for all of these guys. Be a little efficient. Make sure you see down here that we need to have our equation equal to 0. So I'll subtract 9 from both sides, and then write out what a, b, and c are. Okay, and we're just plugging into our formula and solving for the discriminant. Okay, so b squared, making sure we're squaring the entirety of the negative 5, minus 4 times 2 times negative 6. Probably the most common mistake that happens in using the quadratic formula is around negative signs. So just be careful with negative signs here. So we have a 25, and I'm going to see right away that I can turn, we're subtracting what's going to be a negative, so I can turn both of these into a positive. Okay. So we're going to have 25 plus 4 times 2 times 6, 48. And that is equal to 73, which is greater than 0, so we have two solutions to this quadratic equation. Okay, if we were to graph the parabola, it means it would cross the x-axis in two places. All right, next one. And another quick tip, one thing I could have done here to make the numbers a little smaller, in fact, why don't I do that right now? Let's just divide everything by 5. And that's going to make all my numbers just easier to work with, less likely to make a mistake. Okay, and so I have a second set of a, b, and c values, and we're going to end up with the same results because when we divided by 5, we did it to both sides. But now a is 1, b is 6, and c is 9. Okay, so let's do b squared minus 4ac. So 6 squared minus 4 times 1 times 9. And that's easier to do in my head. That's 36 minus 36, so that's 0. So that means there is going to be one solution. Okay, and that also means if we were to graph the parabola, if this 0 was a y over here, if we were to graph the function, then the parabola would intercept the x-axis just once right at the vertex. Okay, and let's see here. Lastly, we have b squared minus 4ac again, so 3 squared minus 4 times negative 2 times negative 9. Again, be careful with those negatives, and I suggest just writing it all out so you can see it written down and not trying to do it all in your head. So I can turn 2 of these negatives into a positive because 2 negatives will multiply together to be a positive, but it looks like I still have a negative sign left over. And let's simplify it a little bit. So this turns into 9 minus 72, which is negative 63. So that's definitely less than 0, right? So that means in this parabola there are no solutions, 0 solutions, or for this equation. And if we were to graph the parabola, where there was a y here instead of a 0, that just means that the parabola would not cross the x-axis at all. This parabola opens down, so very roughly it would be something like that. Okay, so it would never intersect the x-axis. There are no solutions. All right, let's move on and actually solve some equations. And again, I think it's valuable to write down a, b, and c here, okay? And the other, again, just like we just did, I think you could divide both sides by 2. And that it's not required by any means, but it makes everything just simpler and less likely to make a mistake, so we might as well do it. X squared plus 4x minus 21 equals 0. So, okay, so a is 1, b is 4, c is a negative 21. So let's write this out. X is equal to, and let me copy our quad formula from above so we have it to refer to. Okay, so we're just using that formula there. X is equal to negative b, so negative 4 plus or minus a big square root sign. Now b squared. And some of this we can do in our head if we're confident about it, so just turn that b squared right away into a 16. Minus 4 times a, which is 1, times c, which is negative 21. All over 2 times 1 is 2. Okay, let's, again, not try to do it all at once in our head. Let's try to simplify a little bit at a time and solve for x. -4 plus or minus, big square root, 16. These two negatives are going to cancel out to become positives. So what's 16 plus 4 times 21? That is 82. Is that right? All over 2. Okay, I want to double check that, make sure I'm doing that correctly. 142 negative b squared minus 4ac. Okay, so it looks like I'm doing it correctly. Okay, so we can simplify inside the square root. We can tell already that my discriminant is positive, so we'll have 2 solutions. I'm seeing a mistake in here somewhere because I thought I was going to get a perfect square. So let me go back. Mistakes are cool. Let's figure it out though. Plus 7 minus 3, 1, 4, negative 21, negative b plus or minus b squared minus 4 times a sub times c. Found it. Okay. This 4 times 21 is not 82, it's 84, right? So here was my mistake right here. Okay, and you might not know right now why I knew I was making a mistake, but I will address that at the end. Okay, so let's change this guy to an 84. So this turns into a nice square root of 100. So that's nice, all over 2. So we have -4 plus or minus 10 all over 2. So we've simplified as much as we can before we've reached the plus or minus. And now I like just going to a double pathway like we've seen before. So we have a -4 plus 10 over 2 and a -4 minus 10 over 2. So -4 plus 10 is 6, over 2 is 3. So that's one solution. -4 minus 10 is -14, over 2 is -7, so that's the other solution. So those are our 2 solutions. And let me tell you how I knew I was making a mistake earlier on. This right here is factorable, okay? And so this factors into x plus 7 and x minus 3. And so that's how we get the x equals -7 and x equals +3. So I knew we were going to get some nice whole number solutions. But I hadn't, that's how I knew I was making a mistake right there, okay? So quick tip, if it's factorable, why don't you try factoring first? The quad formula takes a little more time. Okay, and then we'll do one more quick one here. Looks like we have an a is -40, not that. A is 16, b is -40, and c is 25. By the way, I would first off try to factor this. It looks like it might be a product of 2 squares, but we're all about practicing the quad formula here, so let's do that. -b plus or minus a big square root of b squared, which is 1600, minus 4 times a times c. And I'm just going to get those in my calculator right now. 4 times 40, -40, nope. 4 times a, 4 times 16 times 25, so that's 1600, all over 2a, which is 32. All right, can you see what's happening here? X equals 40 plus or minus a square root of 0, all over 32. Okay, so we have one solution. When we plus or minus 0, we're not changing anything. When we add or subtract 0, so we get just 40 over 32. Which can reduce down, that divide both top and bottom by 4 is 10 over 8. We can keep going, which is 5/4. Okay, so we have one solution to this quadratic equation, and that's a good place to stop.